In this experiment, your ultimate goal is to calculate the value of KSP for calcium iodate. And you're going to be collecting the data you need to do that using a titration. And what that titration is going to allow you to do is to find the concentration of iodate, the IO3- ion, in a saturated solution. So you're going to be starting with a sample of the saturated solution, which means that this reaction here, our solubility reaction, is at equilibrium in that saturated solution. So you already have this at equilibrium. If you can find these concentrations at equilibrium, you can plug those into your equilibrium expression. That's better, to calculate the value of KSP. So what you're going to be doing in this lab is calculating or determining directly the IO3-, the iodate ion concentration, in that sample of the saturated solution that you're starting with. Once you have that, you can use an ice table to find the concentration of calcium, and once you have that, you can find the value of KSP. So in this titration, we're going to be determining the concentration of iodate by reacting it in a different way, by reacting it with something else in such a way that when that iodate ion is completely used up, when it's all gone, we're going to observe a color change. So in this one, we're going to be using starch as an indicator that before our iodate, before the IO3- is used up, the starch will be a blue-black, really dark color, and that color will disappear as soon as the last of this has been consumed. So by doing that, and by knowing the concentration of our titrant, of the stuff in the burette, which is the thiosulfate ion, we know this concentration, we'll be able to find this concentration. Then once we know this, we can find this, and we can find our KSP. So otherwise, the process is generally the same as the first titration that you did, where you'll be using the molarity and volume of one thing along with the stoichiometry to figure out the molarity of the other reactant, which is the one that we're interested in here. So now I'm going to demonstrate the procedure just so you can see what the color changes that you're looking for look like before you come in and do them in the lab. To prepare this sample for titration, we need a few different things. First, we need a very precisely measured sample of the saturated solution that we're working with. So to measure that out, I'm going to be using what's known as a volumetric pipette. So similarly to a volumetric flask, these have one marking on them. So they're good for measuring one volume. This one is marked 10 for 10 milliliters. So I'm going to fill this up right to here with my saturated solution and then add that into my flask. So I have my 10 milliliters of saturated calcium iodate in my pipette, and I can dispense that into my flask. Takes a minute to let it all out. So to that, I'm going to add about 10 milliliters of 3 molar hydrochloric acid and about a gram of sodium iodide. So the iodide reacts with the iodate to create iodine, which is what's causing this brown color that we're seeing in solution. So just swirling it around to make sure all of my solid has dissolved. That looks good. At this point, I'm just going to add a little bit of water. It makes it a little easier to deal with during the titration if you have a slightly larger volume. Your color changes tend to be somewhat less sudden. So now that is ready to go. So now my sample is ready to go. My burette is filled with the sodium thiosulfate solution. Everything is all set up, so we can start titrating. So throughout this titration, you're going to notice a kind of gradual fading of this brown color. First to orange, which you're starting to see here, and eventually to yellow. Once you hit orange, you want to start to be careful. And once it gets to yellow, you're going to want to stop entirely for a moment. You're not quite done, but when it hits yellow, it means you're really, really close. If it's still a little bit orange, that's fine. You don't want to go too far, is the thing. If you miss it, you have missed it. So this is looking pretty yellow to me, still a slight tint of orange, but that's fine. At this point, we're going to add our indicator. So in this reaction, we're actually using starch as an indicator for iodine. So I have a starch solution prepared, and I'm just going to add a good squirt. So I just gave the pipette bulb a squeeze, squirt that into my flask, and you should see your solution turn this really, really dark blue-black kind of color. If it doesn't, that means you've overshot your endpoint and you're going to have to start over. And now we know that we're pretty close to our endpoint. So we want to take it slow and careful. And what we're looking for our endpoint is for this blue-black color to disappear, and your solution should go pretty much clear. So at this point, we know that we're pretty close. Oh, starting to go. So I'm really, really close. Probably just a drop or two will do it at this point. That was one. You can see it's paler than it was. And one more drop did the trick. So that color disappearing is what you're looking for your endpoint. And at this point is where you would want to record your final burette reading.